Did you ever stop to wonder what lurks beneath the surface of our everyday world? It's not just dirt and rocks or bricks and mortar. It's a vast, invisible, and often unfathomable reality. This microscopic universe exists under our noses, inside us, around us, and makes up every tangible thing that we can see or touch. We're talking about atoms, intricate entities with subatomic particles interacting in ways that shape the universe and, indeed, life itself. At this scale, the ordinary becomes extraordinary, and the innocuous can become dangerous. But fear not, we're here to guide you through this atomic landscape. And yes, there will be surprises along the way, so fasten your seatbelts. Hi Ed lovers, Jay here, and welcome to EdPOP, your go-to channel for the best science facts and curiosities you can't find anywhere else. Before we get started, make sure to subscribe and turn on notifications. That way, you'll always be in the know when we unveil the next big secret of the universe. So, are you ready to dive into the world of atoms? Let's get started. Did you know atoms make up everything we see, touch, and feel? Have you ever paused during your morning routine and asked yourself, what do my freshly brewed coffee and the far-off stars twinkling in the night sky have in common? The answer is atoms. Yes, you heard it right. Atoms are the common denominators in the colossal equation of existence. The world we experience in our everyday lives, from the invigorating aroma of coffee beans to the icy bite of winter air, the softness of your favorite sweater, or the hard metal of your car keys, all of these experiences are made possible by the countless atoms that comprise them. Atoms form the basic units of matter. The screen you're looking at, the chair you're sitting on, the air you're breathing, even the cells in your body are all composed of atoms. In this sense, atoms are the alphabet of the universe, spelling out everything in existence. So, the next time you enjoy your morning coffee or gaze at the stars, remember, you're not just experiencing ordinary objects or distant celestial bodies. You're interacting with a world of atoms, the silent, invisible building blocks of everything. Quite a thought to start your day, isn't it? Did you know over 99% of an atom is just empty space? Ever sat at your table, hand resting on its solid surface, and pondered, why doesn't my hand just pass right through? Well, you're not alone. Despite being seemingly solid and tangible, an atom, the fundamental unit of all objects around us, is over 99.9% empty space. Fascinating, right? Let's put it in perspective. If an atom were the size of a sports stadium, the nucleus would be equivalent to a tiny grain of sand right at the center of the field. The rest of the stadium? Mostly empty. The electrons swirling around this nucleus would be out in the stands, giving us the illusion of fullness. But if that's the case, you might ask, how come everything feels solid? This is where the magic of quantum physics comes in. The electrons in atoms create a sort of force field that repels other atoms when they get too close. This force is what we perceive as solidity. So next time you're leaning on a table, remember, you're not actually touching it. Your atoms are just having a friendly standoff with the table's atoms. It's a microscopic tug-of-war happening right under your fingertips. It's indeed a strange, paradoxical universe we live in. Did you know atoms are mostly composed of three smaller particles: protons, neutrons, and electrons? Atoms, despite being incredibly small, are not the smallest things around. Dive deeper and you'll find they are bustling microcosms composed of even tinier particles: protons, neutrons, and electrons. Protons, carrying a positive charge, are huddled together with neutrons in the atom's nucleus. This is the heart of an atom, an atomic metropolis, if you will. The number of protons an atom has, its atomic number, gives the atom its identity. Change the number of protons, and voila, you've got a different element. Neutrons, the Switzerland of atomic particles, are neutral. They don't carry any charge, but contribute to an atom's mass and stability. They work like the glue holding the protons together in the nucleus, preventing them from repelling each other due to their similar charges. Electrons, with their negative charge, whirl around the nucleus, occupying the massive empty spaces we talked about earlier. Their arrangement and movement define an atom's chemical behavior and bonding capability. So why do these tiny particles matter in our everyday life? From the air you breathe to the screen you're looking at now, these tiny particles play a pivotal role. They shape our universe one atom at a time. It's fascinating to think of how everything is connected on such a minuscule level, isn't it? Hey, wait! Now's the time! Subscribe to the channel to be entertained while learning. It's free! Did you know atoms can join together to form molecules, shaping life as we know it? Let's continue our journey through the microscopic universe. Atoms, as small as they are, don't usually exist alone. They connect, interact, and form partnerships, creating a myriad of different molecules. It's like a social gathering of sorts, on a scale beyond our immediate perception. When atoms come together, they share or transfer electrons, forming bonds. Imagine it like a handshake, a sign of mutual agreement, creating stability. These bonds give birth to molecules. From the oxygen we breathe to the water we drink, molecules are everywhere. But this doesn't stop at simple two-atom molecules. Multiple atoms can link together, forming complex structures. It's akin to individual bricks coming together to construct architectural wonders. Each atom a tiny brick, each molecule a building block of life. The diversity and complexity of life are largely due to this ability of atoms to form a virtually limitless variety of molecules. Take proteins in our bodies, for instance, which are made of millions of atoms forming intricate structures. This is the true power of the atomic world. Can you imagine how many different types of molecules your body is made of? It's almost impossible to comprehend, but each one plays a crucial role in your existence. Astonishing, isn't it? Did you know the atoms in your body are billions of years old and have traveled across galaxies to be here? Let's pause for a moment and ponder this awe-inspiring fact. The atoms that comprise you, the screen you're watching this on, the air around you, everything are ancient. These atoms have been around for billions of years and have traveled through vast expanses of space and time. Sounds like something out of a science fiction novel, doesn't it? But this is the reality of our cosmic heritage. Atoms in our bodies were created in the intense heat and pressure of stars. These stars, in their final stages, exploded as supernovas, ejecting these atoms into the cosmos. They traveled across the universe, eventually becoming part of gas clouds that collapsed under gravity to form new stars and planets, including our Earth. This process is the universe's version of recycling. It's a grand cycle of birth, death, and rebirth. The atoms in your body today were once part of ancient stars and cosmic entities. Have you ever considered that we are all made of stardust? So the next time you look at the night sky, remember, you are not separate from it. You are part of it, a child of the cosmos. What a remarkable journey we've all been on without even knowing it. Did you know atoms can be split, releasing vast amounts of energy? Consider a small, seemingly insignificant paperclip. It's hard to imagine that it contains an immense amount of energy, but it does. That's because each atom within it holds a substantial amount of energy in its nucleus. When these atoms are split apart, a process called nuclear fission, they release that energy. And this energy is not just considerable, it's staggering. Nuclear fission powers our nuclear reactors, providing electricity to millions of homes and industries worldwide. The principle is simple yet potent. Split a large atom, like uranium or plutonium, and it releases a huge amount of energy. This is the same energy that lights up our cities and powers our industries. But this immense power can also have a darker side, demonstrated tragically in atomic bombs. Yet, let's imagine for a moment that we could tap into all the energy within the atoms of a simple paperclip. The result would be nothing short of astonishing, equivalent to thousands of liters of gasoline. So, do you know what would happen if we could harness all the energy in the atoms of a paperclip? It's a fascinating thought, isn't it? And it underscores just how much energy is concealed within the realm of a tiny atom. Did you know atoms vibrate, and this vibration changes with the change in temperature? Picture a bustling city center during rush hour. Everyone's in motion. It's not much different on the atomic scale. In fact, atoms are perpetually in a state of motion. They vibrate. This vibration isn't random, it's a direct manifestation of their kinetic energy, the energy of motion. Here's the interesting part. As the temperature changes, so does this vibration. The hotter it gets, the more vigorously the atoms vibrate. That's because increasing the temperature effectively means giving more kinetic energy to these atoms. When you heat a solid piece of ice, for example, its atoms vibrate more and more until they can break free from their rigid positions, turning the ice into liquid water. Heat that water further, and the atoms gain enough energy to break the liquid bonds and become a gas. Now, think about a hot cup of tea. Left untouched, it doesn't remain hot. Why do you think that is? The reason links back to those ever-vibrating atoms and the way energy is transferred. Through this lens, even everyday phenomena become a part of the incredible atomic world that underlies our existence. Just as a masterpiece is composed of individual brushstrokes, the universe, from your morning coffee to the farthest galaxies, is crafted from an intricate tapestry of atoms. These ubiquitous entities, though seemingly invisible, shape everything we perceive. So, next time you gaze at the stars or hold a cup of coffee, remember this atomic journey. Don't forget to like, subscribe, and comment. Remember, every atom in your body has a story to tell. Stay curious and keep exploring.